full spectrum of technologies, going from sort of the small, common filtration types of technologies to the innovative technologies that have come out over the last 10 to 12 years, microfiltration, ultrafiltration, reverse osmosis, to some of the really complex technologies like evaporation and crystallization. Membrane bioreactors, which are hollow fiber ultrafiltration membranes that are used primarily in wastewater applications as a final filtration step of a biological waste treatment plant. Now, if you design your membrane bioreactor properly, you can reduce your footprint, you can get a higher quality effluent, but even then, about 10 or 12 years ago, anybody that was implementing a membrane bioreactor was paying a premium over conventional technologies like waste-activated sludge aeration basins and clarifiers. But over the last 10 years, GE has made a significant investment in improving the membrane bioreactor technology to a point now where it is even with conventional technologies. So not only the people that want to implement membrane bioreactors can do it for the same price on a 20-year life cycle evaluation basis with conventional technologies, they can do it with a smaller footprint and they can get higher quality effluent. Now, that's in some cases a so what. Well, if you have that high quality of an effluent, you can now reuse the water. Why discharge it into a receiving stream when you can reuse that water for beneficial use? And that's one of the keys that we're trying to drive and make people aware of in events like today. Well, I think the effect is smaller footprint, lower energy usage, and a higher quality effluent water. So now you can reuse that water as opposed to just discharging it into a receiving stream.